Okay, we're back. So we've drawn out our diagram from the widget go problem, and we're about to compute several numbers for the diagram. We're going to start here. And so um, it's common practice if you're at a starting value here that you can just put as your activity, we can say start, but then the activity has duration 0. Okay, so these numbers are things we want to compute. So ES stands for the earliest time the activity can start. So early start, the earliest time the activity can start. By the way, our book is calling that ET instead of ES. And in fact, our book only computes these two numbers. So I think it's better to do all of these numbers. EF is the earliest finish time. So it's the earliest time that we can finish. Okay, and so you can kind of see what's going to happen, right? The earliest finish time is going to be the earliest start time plus the duration. Did you catch that? Earliest finish time will be earliest start time plus the duration. So I've got that as a note down here. And the latest finish time is this one. It's the latest time which the activity should finish without needing to extend the overall job. Okay, so again, that's the latest time that the job can finish, but still complete our job. Okay, and so the latest start time would be what? It would be the latest finish time minus the duration, right? So again, the latest start time would be the latest finish time minus the duration, and so I've just made a note there. Once you get used to these, it goes really fast. Okay, so let's see how this works. There's just a few things you have to pay attention to as you're filling in these numbers. The start time is just going to start at 0, and so you can just fill it in with zeros all the way. And so what we're going to do is we're going to fill in the top layer as we go forward in the network, and we're going to finish it off with going with these by filling in those when we go backwards in the net. Okay, so we have to do a forward pass first, and then we'll do a backward pass. Okay, so in the forward pass, we're filling in our early start and early finish. So let's take a look at node A. What's the earliest time we can start? Well, there's no activity before A, so the earliest time we can start is 0. What's the earliest time we would finish? Well, 0 plus 6. Good. How about activity B? Is there any predecessor to B? Or anybody over here? Anything that needs to be finished? No. So therefore, it can start at 0. And then when is it going to finish? When is the earliest time it would finish? That would be 0 plus 9, or 9. Good. Let's go to C. Now C, when's the earliest time it can start? So remember that C has to wait for A and B, right? And so if A finishes the earliest at 6 and B finishes the earliest at 9, what would C be? Right there. Yes, it has to wait for both of these, so this would be 9. Okay, so that means the element here in EF would have to be 9 plus 8, or 17. You see how that works? How about this one? Activity D, it depends on A and B being finished. So just like our previous analysis, A finishes at time 6 at the earliest, B finishes at time 9, so therefore D has to wait for both, so therefore it has to wait until 9, right, before it can start. And so 9 plus 7 is 16, and that is the earliest time it can finish. Very good. How about node E here, or activity E? E just was waiting for D. D can finish at 16, therefore E can start at 16. And then because we have a 10 duration, the earliest time E can finish would be 26. Good. And then we have F now. F has to wait for both C and E. So C can be finished at time 17, but E is waiting until time 26. So therefore, F is going to have to wait till time 26. Good. And then, so what's the earliest finish time for activity F, it would be 26 plus 12. So that would be 38. Good. And so we are now finished with our, by the way, you could put an end goal if you wanted to. And in that case, again, we would just have a duration 0. So you could have like end with duration 0, and then you could put like a 38, 38. This would just have 38s everywhere. Okay, good. All right. Now we want to work backwards. And so we're looking at the time here. And so we need to start things off so with the latest finish time. And so we're able to get the job done in 38 minutes. So or 38 units of time. So let's go ahead and put that in as our first latest finish. So then what would the latest start time be? It would be 38 minus 26, or 38 minus 12, which is 26. Good. Okay, now, what about job E? What's the latest time that job E can start and still get everything finished on time? Well, job E better get started at time 26 because activity F wants to start at time 26 at the latest, right? And so E would have to also start at time 26 at the latest. And so 26 minus 10 would be 16. So that would be my latest start time would be time 16. Good. What about C? So activity C, well, it should start before, or the latest finish time for node activity C would be 26 again, right? Because I don't want to get any further than that. So we put in our 26. But now, what's the latest start time? The latest start time would be 26 minus our 8 duration, which gives us a value of 18. Good. And now how about activity B? Right, so activity B, the last time is either going to be, I better finish this one off first. So 16, let's see, node D has to wait until time 16 to start. So, and there is no other node to take into account, so I'll just put the 16. 16 minus 7, 9. So you're probably noticing something, right? Something interesting is happening here. Okay, so now let's go to node B. Now, what is the latest finish time for B that won't make all my other jobs shift forward? So it's either going to be 18 or 9, right? Would it be 18? Well, it doesn't have to be 18, right? Because there's time between time 9 and time 18 where nothing's happening. So B could start as early as the minimum of these two. And so therefore, it would be the 9 in this case, right? And then we would take away 9 for the duration, and that would be 0. Now let's take a look at node A in the same way, right? Node A, the latest finish time is either 18 or 9. It's the minimum, so that would be 9. And then 9 minus the duration 6 would give us 3. Good. And we're finished. So by the way, you'll notice something. If a node like this has two predecessors, like A and B, then remember how we got the 9 here? We took the maximum of these two values, and the maximum went there. That was the max. But then when we were going backwards, where did this 9 come from? This 9 came from taking the minimum of those two. Okay. So when you're going forwards, you're looking at the predecessors and taking the max. And when you're going backwards, you're taking a look at the predecessors, but taking the min. Okay. Good. So that's just well, of course, I think it's fairly straightforward to reason it out as well. All right. So let's finish off this example. So the last value we want to compute is called the slack. Our book calls it total float, but we're going to call it slack because most other books call it slack. And the slack is actually either the difference between LS and ES, or the difference between LF and EF, and you'll find that these two are always the same number. Okay, so in this case, for example, the slack is 0, and so I'll just make a note: slack is 0. Slack is 0. Let's see, what's the slack here? Slack is 9. Is that right? What's 26 minus 17? Is that 9? Yes, it is. So 9 minus 6 is 3, and slack is 0, and slack is 0. Good. Good. All right. So you see what's happening with the slack. The slack is telling us that we could shift the time forward by 9 units before we run into trouble, uh, before we have to shift our times forward for the entire job. Oops, I ran off the page there. Can you still see that? That's slack 9. That's slack of 3. Okay, so there's some room for maneuvering in here that doesn't exist for these other ones, right? Does everybody see that if you start here and just focus on these jobs, no slack in these jobs means that if I have to delay any of those jobs, it delays the entire project, right? And so this red path right here is called the critical path. And so when you're doing project management, it's really important to find out what that critical path is, because anything happens to the jobs along the critical path, and that's going to mess up your entire project. Very good. All right. So what we're going to do next, um, you might write down these definitions, and then we're just going to run a couple of examples. And then for the homework for this section, we're just going to take a look at a couple of examples. So I'm just going to give you like the list of activities and the durations and the predecessors, and you'll draw the diagram, and then you'll figure out what the critical path is. All right. I'll see you later.